Hey guys, welcome to GDG Accra live event streaming from Accra, Ghana. Today we have something special for you guys, and I'm Shadrach Inusa. I'm here with my colleague Hannah. Hey, hi Hannah.
Hi,
Yeah, Hannah, what's up?
I'm good. How are you too?
I'm also doing awesome. Yeah, this is our first event, streaming live. That's from GDG Accra. And what are we expecting, Anna?
So today we have a session with Paul Ruiz, who is a fab, just a sec, who is the developer programs engineer on Firebase with a background in Android and IoT development. So
Okay.
outside of work, he makes movie props as a hobby and is a member of a Star Wars costuming charity where he
Wow.
volunteers at events as various movie characters, including an Imperial Snowtrooper, an
Wow.
X-Wing pilot, or Tusken Raider.
Wow.
Yeah,
That's
so
awesome.
quite an interesting personality.
Yeah, sure. I can't wait to hear from him as well. I can't wait to learn more from him. And I heard he's at the back, he's at the airport, right? So we have to bring him in. He's in Accra virtually. Yeah, so Paul is with us virtually from Accra. So I think, Anna, you have to go and bring Paul in. So I hand it over to you, Hannah, to bring Paul in. Yeah.
Okay, so hi everyone once again. Let's welcome Paul, who, like I said, is a developer programs engineer on Firebase. Yes, and is going to take us through rapid prototyping with Flutter and Firebase. So let's welcome him.
Hey, hi, Paul.
Hey everyone, how's it going?
Awesome, awesome. We
Awesome.
are glad to have you here virtually live in Accra.
Yeah, I'm excited.
COVID-19 has made it possible for you to be in Accra within. So that's awesome. Awesome. So, Paul, we would like you to have a short, um, I think, description about yourself. You tell us a little about yourself. And that's awesome. You can just pick it up from there. Yeah. Thank you very much.
Okay. Yeah, so hey everyone, my name is Paul Ruiz. So again, I'm a developer programs engineer on Firebase. So I help with writing blog posts, sample apps. I do a lot of work on the Flutter Fire open source library as well recently, putting together examples and whatnot. Like we had mentioned earlier too, I also do a lot of costume props and whatnot. So I don't know if you're able to see the guy in the background there, but that's one of the ones I've put together. So it's just kind of a hobby that I have. Um, Other than that, I don't know. I don't do too terribly much. A lot of gardening, have chickens and pets. So nothing too fancy.
Sure, sure. So, Paul, we'll hand everything over to you now. So, you
Okay,
take us through the event. Yes, awesome. Yeah. So, thank you very much.
perfect. Yep.
All right, so
All right.
guys, stay in touch. I will also put in the link here to ask Paul any question you have. I will put in the Slido link here, so you can ask Paul any question you have at your end as well. Yeah, so Paul, over to you now.
Okay. Let me go ahead and share my screen. Let's see. And that should work. Perfect. All right. So hey everyone. Again, my name is Paul Ruiz. So today we're going to talk about two tools, Flutter and Firebase, and how they can be used for rapid prototyping. So whether it's at a hackathon with only one weekend to build something presentable, or you have an idea for an app that you want to test out before really investing in it, a lot of us have been in a situation where we want to build something that gets the job done quickly. During the normal prototype development process, developers plan out what their app should do and how it should function, research the feasibility of the idea, map out their architecture, pick their tools, and build a clean and organized prototype, right? So yes and no. I know I'm definitely not one of these people. So while some people will stick to that formal process, a lot of us just want to like build out a proof of concept app by just opening up their IDE and start coding and just kind of figure it out as we go along. So given this, I'm going to talk about the two tools I mentioned earlier, Flutter and Firebase. Both of these are easy to use and address different development problems. Flutter is for client-side development, and Firebase is for the backend. Both are designed to be easy to use, and they're well supported with content and documentation to make getting up and running as easy as possible. So while I wouldn't say this is necessarily a deep dive, this presentation is going to look at a lot of code and tools that will hopefully be helpful in getting you started with Flutter and Firebase. While it might be a lot up front, I can't stress enough that you don't need to memorize everything. All of the code that I show in this presentation will be available in the slides when I share them at the end of this talk. So you'll be able to go to Twitter, find me, and actually get the slides for this. What this talk isn't is a live coding exercise or a workshop. So as much as I'd love to do this presentation that way, I've tried a couple times and just isn't really doable with the whole online streaming. Turns out when you run 4 IDEs and emulator while streaming, your computer just completely slows down. So that'll be something that we she'll be able to save for a later date when I can actually see everybody in person again. So with that, what I hope to do with this talk is help you leave with the vocabulary to look into both of these tools further when you're ready to use them. So with that, let's just go ahead and get started. So first, let's talk about Flutter. It's a UI toolkit that uses the Dart programming language for building native apps for multiple platforms on top of C++ using a 2D engine called Skia, which is the same graphical engine that's used by Chrome, Android, and a few other platforms, all from a single SDK. Since everything is built from a single code base, you can create your prototypes for multiple systems, such as Android or iOS, without requiring specific developer knowledge about each platform. Flutter is also completely open sourced. Not only is Google working on it, but so are many members of the developer community. Rather than being walled off from the internal workings of the tool, you can dig into the code to see exactly how Flutter is doing what it's doing, as well as send your own pull request if you want to have put in anything to improve it. So far, there's been about 18,000 contributions from the global developer community into Flutter, and that number keeps rising as more people are trying the platform and figuring out how everything works and whatnot. So aside from Flutter being cross-platform, you're probably wondering when you should use it for rapid prototyping, especially since there's already other tools out there that do similar things. So like most development decisions, the answer is basically it depends. While Flutter isn't the only tool that can work cross-platform, it is designed from the ground up specifically for creating apps quickly. It's able to tie into device hardware using external plugins and packages that can be imported into your project and uses widgets, which we'll dig into in a bit more soon, to create UI components programmatically rather than requiring something like a layout file or a storyboard. One other feature of Flutter that I think is super valuable is hot reloading, so you don't need to restart your entire app to test small UI changes. Instead, UI changes will automatically be applied to your running apps as you change various values. Following up on the it depends answer, there's also going to be times when Flutter isn't the right solution for you. And it's better to figure that out early on in the development process. So for starters, while games are a lot of fun to develop, Flutter isn't really at a point where you can make most types of games quick enough to call it a rapid prototype. You'll need to write a lot of components from scratch that other platforms currently give you out of the box. Additionally, calling native APIs directly just isn't super easy. Normally, you would write native Swift or Kotlin code and use platform channels to communicate back and forth to the native level through a bridging process. So while this isn't necessarily a deal breaker, it is more work than just throwing some UI together and calling it good. The next thing to consider is audio support, or rather the lack thereof. So while audio isn't supported by native widgets, there are third-party plugins out there that can provide this functionality. Which brings me to my next point. While there's a ton of plugins out there for Flutter, some third-party libraries that developers have grown to love just aren't really available right now. You'll have to weigh the necessity of these things versus working with what Flutter has before deciding to use the tool. So fortunately, there's an alternative to pretty much most things, but you would have to dig into exactly what you need and what is available before you can make that decision. So finally, Flutter doesn't really have support for additional form factors like watches, televisions, and cars. So right now, Flutter does have very limited support for things like Wear OS, but no support for platforms like tvOS. So like I've talked about already, one of the biggest draws of Flutter for app prototyping is that it's an easy-to-use tool for creating custom UIs. The first part of this presentation is where this talk starts to get into the technical side of things. So I want to give an overview of the way Flutter can be used to build out UIs. So when you're working with Flutter, everything is a widget, and all UI is described by widget in a tree structure. One key term that you'll see in Flutter documentation around this is aggressive composition, which essentially means that aside from some very basic widgets, the widgets that you use in your apps, either custom ones that you put together or those that kind of come with the platform, we've made up of other more simple widgets all kind of put together. So you can think of these like Lego bricks where you just kind of connect them together to build whatever you want. While there are hundreds of widgets out there, I want to go into just a few of them at a really high level to give you an idea of this fundamental part of Flutter. So a lot of you know, you can't really start anything in the software world without hello world, right? So let's take a look at an example to get an idea of how Flutter uses widgets to create a very bare bones user interface. So all Dart apps, which you might remember is the language that Flutter is built using, or like is used with Flutter, use the main function as their entry point. And in there, you can initialize various components and start your Flutter application. You can also see a center widget in this example, which will center your content in the middle of the device screen. Next is a text widget that, as you could probably guess, is used for showing some text. It's pretty self-explanatory there, which is nice. And then this text widget also has a few properties that can be applied to it. The first one is the string that will be displayed by the text widget, and the second is a named optional property, text direction in this case, that can be used to customize the widget. So all said and done, you end up with this stunning example of a beautiful, simple user interface that does pretty much nothing except display some text. But it's hello world, so it's okay. So before we really get into some of the more useful widgets, I wanted to divert for a moment to touch on how Flutter can be used on multiple platforms. So we've all seen the apps built with multi-platform tools where they just don't look quite right compared to the system standard UI, such as Android apps that look like they were designed for iOS. What makes Flutter handy here is that it's able to tell what platform it's on so you can apply the proper UI elements for your app based on the OS. You can see in this example that we're using the same app on both iOS and Android devices, but they each look native to their respective platforms. This functionality is available through the Dart IO package that can be imported into your apps. When the user is on iOS, the platform.ios flag will be set to true. If the user is on a different OS, then that flag will come through as false. There's also an is Android flag that you can use, so if you wanted to test it that way. So other people that are also Android developers like me, at least with a background in it, don't have to feel left out, which is nice. And then once you get to that point, you can also see that we're using a standard ternary statement here to expand the proper widget for whatever platform the user is on. So in this case, we'll check that flag. We'll see if it's on an iOS device or an Android device. And if it is on an iOS device, we're going to expand the Cupertino slider here, which is essentially just a normal slider like we have just below it, but it'll be styled to look like it's on a iOS device. And then if the user is not on an iOS device, then we'll just expand the regular slider here as the second option in that ternary operation. And then finally, you can see that both of these sliders have properties that can be set on them. While the base properties are the same in this incomplete example, there are some differences in the components, such as a background color property that only applies to the regular slider. You'll want to check documentation or the source whenever you use the platform-specific component to make sure that you're setting the correct attributes rather than just assuming that they're always going to be the same. So since that last slide, for the sake of space, used an incomplete code sample, I want to include a complete sample for a slider here for everybody. The value of the slider is a double that is saved outside of the widget. The active and inactive colors are set for the material design version of that widget, and the onChange property is set to maintain state as the slider is used. One thing to pay attention to is that if the onChange property isn't set, then the slider is unusable, so it will just not drag or change or anything as you're actually trying to interact with it. Like a lot of things in Flutter, this widget is pretty straightforward, but you will need to look through the source or documentation to understand why certain properties are needed and what they do. The next component that I want to talk about is the list, since honestly, most apps are essentially just list and detail screens. There's actually a lot you can do with lists, like setting them up for infinite scrolling, having items react to long presses, and adding various custom composite widgets that each do different things. To keep everything simple for this example, we'll start by just looking at the code for a super basic list of generated text items with a circle icon. After that, we'll take a moment to look at adding a swipe to dismiss feature to our list, similar to what you can see in this demo image. If you're coming from the Android world of recycler views, you'll hopefully be surprised by how simple this is, especially in comparison to how Android uses standard view holder patterns and decorators and some other things that just add a bit more complexity than what we have here. So the first widget is the scroll bar. While it's not necessary, it does provide, as you can probably guess, a scroll bar on the side of a list so users know how far along in the data they are. After that is the actual list view widget, which provides the scrollable area that contains and controls the list items. This widget also has a collection of properties that can be set to customize the list. Here you can see that we're setting a padding to the top and bottom of the list view, but the only required property is the children array, which will house the items that exist inside of this list. the next part is where this component gets a little bit more interesting. While you can include a simple list or data array structure of other widgets, there's also this great list.generate call that can loop a set number of times to create widgets for your list view. In this case, we'll simply create 100 items that will be displayed in our app. Each of these 100 items will be made up of a single list tile widget, which implements the material design spec for list items for you out of the box and is generally used to display some text and a leading item like an icon for each of the list items. As you might expect, this list tile has its own properties. The first one is the exclude semantics widget, which wraps a circle avatar. This will display the index from the generated list as an icon at the start of the list item. And since it's wrapped by that exclude semantics widget, it won't be read by accessibility tools like screen readers, meaning it doesn't just add noise for users that need to use these tools. It's worth noting that the exclude semantics widget should only be used sparingly, and really you should only be using it for very specific reasons that are beneficial for your users, because you don't want to get around accessibility tools just to get around them. Really, it's just you don't add noise for people that actually do need to use those tools. Oops, excuse me a second there. Let me fix that. All right, the final part of the list tile widget is our list view. In our list view is probably the most simple. It's just a single string in a text widget that represents the content of our list item. So while that wasn't very much code, it does create a simple list view for our Flutter apps. I actually have that exact code running in this graphic, but I also modified it to include a swipe to dismiss feature, so we can talk about how you can add something like that to your prototypes. So let's go ahead and just kind of dig into that now. The core of this functionality is yet another widget, because pretty much everything inside of Flutter is going to be some form of widget. In this case, it's going to be this dismissible widget. What's nice about this is that we don't need to replace anything in our current list to make swipe to dismiss work. The dismissible widget just takes the list tile widget from the last section and adds it as its own child. If we ran our app at this point, each item in the list view would be swipeable and would also be removed from the list view if completely swiped off the screen. While optional, the background property does help let users know when they are swiping away on a item by changing what appears behind the list item during that action. So in this case, I'm adding a new container widget that sets the background color to a very light green. You can also set a secondary background color if you want the user to see a different background when swiping to the left versus the right. Now, one thing that's worth noting here is that since the background property accepts any widget, you can do some fun and interesting things in this area, like loading in an animated GIF for the list item's background. So while this doesn't necessarily mean you should, it is kind of fun just to see what you can do when you're playing with things. Of course, performance and whatnot is a whole other story, which we're not going to get into with this part, but you probably shouldn't load a GIF in for each of the backgrounds, but it's kind of fun to know that you can. So now that we've looked what we can do with the background of a dismissible, let's get into a couple more properties. The first one is key. This is a required property that needs a unique value to keep things in order while removing items from your list, as it interacts with the actual data structure driving the UI. To keep things simple, you can usually just use Flutter's unique key class to assign a unique key to your dismissible list item. Finally, there's the onDismiss callback. While this isn't required by the dismissible, it is useful when you want to display something to your user to let them know that they have removed an item from your list. This is also where you'd notify your backend that an item was removed if it's hosted remotely. That way it doesn't show back up the next time your user opens up your app. And then since they're fairly often the widgets that are actually used in the list views, let's wrap up our general discussion of widgets by briefly talking about the card design pattern. Like most widgets in Flutter, this snippet is fairly lame. The size box means each card will have a predefined height, and that size box will wrap a child card widget, which sets some general properties for the card, like the shape and basic behaviors. Next up is the child of that child, which in this case is an inkwell. The inkwell is kind of an interesting widget, as it's what the card uses to figure out interactive touch areas. You can also set a touch area color, such as the ripple effect in Android, by setting the splash and highlight color. If you don't want these to show up, you can set these properties to colors.transparent, like we're doing here in this example. Finally, the inkwell has its own child, which is the actual content of the card that the user sees. In this example, it's a custom composite widget called Travel Destination Content. Despite the complexity of the widget that we've extracted away here, you can see that you can add any sort of widgets that you would want into your card. So overall, the snippet is just kind of a great example of how Flutter uses a hierarchy of widgets to build a UI for your users. So far we've covered a handful of widgets, but we haven't even broken the surface on how many are actually out there. To learn more, I really recommend checking out the Google Developers YouTube channel to find the Widgets of the Week videos, and to check out the official widgets reference documentation on flutter.dev. You can actually see this as a screenshot that I took, but I've gone through all of them, totally worth it. It actually is only a couple hours long. If you watch 1 through, I think they're about 80 or so now. Pretty worthwhile though, definitely would recommend it. So now that we've covered a handful of common widgets, let's get into some stuff that's a little bit more interesting and useful when it comes to learning the platform quickly and creating some prototypes. I'm going to just see if I can't fix this again. Sorry about that. My USB is starting to go out, so my power cord isn't staying. There we go. So the first tool that's awesome for getting up and running quickly is the Flutter Gallery app. This app is entirely open source and available on GitHub, meaning you can grab whatever functionality you like out of it to throw it into your prototypes. It goes over a collection of widgets that can be used with both material and Cupertino stylings, and has a lot of other useful features that you can mess around with in this like playground app. So each widget section in the Gallery app includes a descriptor and can bring up the code that was used to create that section. Each widget page also has an icon at the top that will take you directly to the official documentation for the widget that you're looking at. Additionally, there's a variety of tools that can show you how to do animations, media playback, or display each of the available stock colors in Flutter to help you get your apps put together even faster. The Gallery app also includes case studies, so you can see how common features work together in a big picture scenario, rather than just a bunch of one-off widgets. You can see a staggered grid view, hero animations, which is the ones where if you click on something, it will kind of expand into the full screen version of it. And just a bunch of other, like circular animations and different things in a single list, and I don't know, just a whole bunch of stuff. So this is great when you're trying to put together a quick prototype, as you can get examples of animation and interactive components out of the box, rather than spending a bunch of your time trying to figure out how these things are going to work through random blog posts online, Stack Overflow, documentation, if you just don't have the time to actually devote to looking through all of that. Though, honestly, the documentation is great. So, yeah. But speaking of documentation, as you probably noticed, I do mention that a lot. I'm a huge fan of what the Flutter team has already put together, especially since a lot of it isn't just the standard, this component does something sort of stuff. One of the things that they have is the Flutter Cookbook, which is a documentation page containing various code samples or recipes for common tasks that you might want to do in Flutter. So this is just a sample of what's there, but you can see that it's a lot of great content that you use in almost any app, such as animations, design elements, and networking. The next thing to talk about, plugins, are essentially a fancy word for libraries or modules that are one of my favorite things in Flutter. Because the development community is so active and passionate about the platform, they have created thousands of open source plugins that you can use in your apps to easily accomplish tasks without having to reinvent the wheel. You can find most of these plugins by using pub.dev, a site created by Google for searching through plugins and finding their documentation and source code. So with that, let's go ahead and take a look at a few of the useful plugins that are out there and how to implement them. So while there's a ton of great third-party plugins out there, I figured I would start with Google Maps, since it's actually one of my favorites, and it's my go-to whenever I need to display location information for my users. So in this section, we'll go over the code that I use to make this exact demo image. So you can kind of see just what it's doing is it starts the map, and then you can kind of click through it to zoom in on like where my office location is and show some information about it when I'm actually in the office. So Google Maps functionality is all wrapped by a Google Map widget that can be displayed on the screen. This widget has the bulk of its functionality handled by the on-map created future method. If you're not familiar with futures from other languages, they're basically one of the ways that Flutter handles asynchronous operations by figuring out what to do in your app before an asynchronous action, during the action, and after the action has finished. If you're familiar with Android development, then you can basically think of these like async task, but kind of less awful. So futures will come up a few times during this talk, though a really detailed look into this feature is a little out of the scope for this presentation. If you are interested, though, I super recommend going and looking up how they work, especially if you are going to continue on with Flutter development. So this method is triggered once the maps data has finished loading. The example for this presentation will load the location of Google's offices around the world as a list of objects that will then be displayed as markers. Once those office locations are loaded, the map data structure of markers will be cleared, and then we'll loop through each office. Each office will then be converted into a Google Maps marker that designates the office's location, name, and address. We can also add an action to the OnTap method, or property rather. So let me see. What this will do is it'll bring up a navigation screen if we want, or we can display additional information about a specific marker's location, like the address that pops up over the marker. Finally, we'll take each of these markers and add it to the global map data structure that we cleared earlier. Back to the Google Map widget, we can set the initial camera position and zoom level. So in this case, it's just a very high-level view that is centered in the middle of the ocean. And finally, we can add a set of markers to be displayed on the Google Map. So next up is Flutter. Flutter, it's kind of a hard one to say. It is a third-party plugin that I thought was just kind of too cool to not include in this talk. So this plugin is great when you want to animate icons, buttons, and other items in your app to add some extra kick to your UI, which is always great when you're trying to sell an idea to someone or show it off for a hackathon judge. It's worth noting that you can do some of this manually using native widgets like Animation Builder or Transform, but it's just not nearly as easy as using this library that goes with it. So using their animation website, rive.app, you can stage out animations that will then get converted into a vector animation file that you can export and run in your app. Overall, it took me roughly 20 minutes of a tutorial on YouTube to learn how to actually make this fading and spinning star animation, and just properly set up the keyframes. But luckily, once you know how to put together one, it's really easy to make other animations that'll stand out in your app. Once you have your vector animation file exported, using it is as simple as initializing the custom Flare Actor widget in your app, then assigning it the animation file that you wanted to run. You'll also notice that I'm listing the animation title as Go in one of the properties, which is what I call the animation in the web app before I exported it. So you can see how it'll be exported in the animation file JSON object here, as well as what I'm actually going to reference from the code in Flutter. So while we've talked a lot about rapid prototyping for apps, it's becoming more and more common for people to need to make prototypes that consist of an app with a hardware device. In this next section, I want to briefly touch on FlutterBlue, a third-party plugin that helps you communicate with Bluetooth devices using a Flutter app. While I won't go into a lot of detail here, this is an area worth knowing for people that need to make IoT prototypes, so I just want to make sure it's at least introduced. The first thing every Bluetooth app needs to do is scan for advertising devices. You can use this by calling start scan on a FlutterBlue instance. You can also, and probably should, set a timeout duration so that the scanning stops after a period of time, especially if it doesn't find something, so it doesn't just keep running consistently. Next, you will listen for the results to be returned from that scan. And then you can act on those results, like saving a particular device based on the name or RSSI value, which is essentially the received signal strength of that device. After saving your device, you will probably want to connect to it using the connect method. Then you can discover the services that are being broadcast by that Bluetooth device. Depending on your setup, you may also want to loop through each of those services to do something with them in your app. One other thing you might want to do is pull each characteristic, or essentially a piece of information, from the broadcasted service. Not only can you read those characteristics, but you can also asynchronously write back to your hardware device by using those characteristics. The final thing I want to cover with FlutterBlue is that you can attach a listener to characteristics that will be notified anytime new data is pushed to a characteristic by another device, allowing your app to stay reactive while dealing with the real world. To wrap up our introduction of Flutter, I want to talk about one of the more common tasks that you'll run into when building a new app, which is retrieving data from the internet and parsing a JSON payload into Dart data objects. This sample will go over a simple list item that pulls data from the Etsy API to display inventory amounts for each listing in a single shop, though the same idea can be carried over to countless other scenarios. The first thing you want to do is use a feature builder in your app, which you may remember is a specific component in Flutter that lets you decide which widgets to show during or after loading data. In this case, I'm using a new method called future listings. This method is asynchronous and returns a future object with a type of listings which is a custom object that represents the array of items coming from the API. This method will use the HTTP package to get the data from our API endpoint. And if that endpoint returns a 200 success code, then we'll use the JSON.decode method to convert the response into a JSON object, which will then convert into a listings object. This is done from a custom object that I created called listings, using some dark magic under the hood that converts a JSON map into a list of objects with a type of dynamic, which will essentially just mean they're kind of like undefined generics, if you're familiar with that from Java or some other languages. So once we have the data from that feature, we can do another conversion to switch the list of dynamic objects into another custom object, listing, which is just an individual item from the earlier listings array, using similar JSON conversions. This example also sorts the list using a simple A to B compare operator. So while that sorting isn't actually necessary for this case, it is something that seems like people would want to use it when they're putting together prototypes and apps and whatnot that deal with data. So I thought it'd be kind of nice to just kind of include how you would do sorting here. So after all of that, you can create a new list view of list tiles, just like we did earlier in this presentation. For the last part of the sample, if there isn't any data in the future builder, such as during the time the data is loading, then we can just display a circular progress indicator until the results are available. It's also good practice to handle error cases in the future builder, though I didn't do this in this example for space and a little bit of time. So the next part is when we're going to get into how you would use Firebase with Flutter. So first, let's go into the official pitch for Firebase. Firebase is an application development platform with a mission to help app developers succeed by using Firebase products. Firebase accomplishes this by taking common problems and developer tasks that occur during a product's lifecycle and making them easier to solve, be it by providing more information about your apps and their performance, or providing tools to handle complex problems like security and network connectivity when storing data. Firebase is divided into three main categories of tools with specific goals: helping your users, or helping you build better apps by making complex coding processes easier, improving app quality by helping you catch issues early and fixing them quickly, and helping you grow your app by understanding how other people are using it and engaging with them in meaningful ways. So as you can see, there's actually like 20 products here in Firebase. And while that may seem like a lot, today we're only going to talk about a subset of all of the Firebase features that are here, just the ones that are the most relevant to rapid prototyping. So again, the goal here isn't to overwhelm you, but rather let you know what's available when you need it. So before you can start diving in using Firebase in your apps, you'll need to create a new project. You can do this at console.firebase.com and basically just type in a project name and hit next a few times to get set up and into your project's console dashboard, which is what you see here. The next step will be linking your apps back to Firebase. In this talk, I'll only touch on the Android and iOS processes. For Android, you will need to enter in your app's package name, which you can find in the Android manifest.xml file in your project, and potentially the SHA-1 certificate for your signing key. One thing to pay attention to is the SHA-1 certificate is optional, and I really recommend that you skip using it unless you're using one of the few products like Google Sign-In or Dynamic Links that absolutely needs it. There's a few edge cases with the certificate that might cause you some problems down the line because Android package names and SHA-1 pairings are actually globally unique in Firebase, but that's a whole other topic that's kind of out of scope for this presentation. So after that, you'll need to add some code to your build.gradle file for both the core Firebase and specific Firebase products that you want to use. You'll also be provided with a Google Services JSON file through the setup process that will need to be copied into your Flutter app. The iOS process is similar, if not a little bit easier. So basically, you'll put in your bundle ID and then add some information to your plist file in your app and install the pod files for the products that you want to use. After that's done, you should be golden for using Firebase for both iOS and Android with your Flutter app. So the first feature I want to go over is authentication. While it's not the most flashy feature, there's always that one hackathon judge or whoever that's going to ask you about security. So you might as well toss it in since it is easy enough to use. Firebase authentication will allow your users to log into your app using a username and password, a phone number, a third-party identity provider like Google or Facebook, or a few other options. For simplicity, I'm going to go over just a few of the more commonly used authentication features. So let's go ahead and get started by discussing user authentication using an email and password. A major part of the setup process occurs in the console. So aside from adding your app to Firebase and updating your plist or including your Google Services JSON file, you will need to enable each type of Firebase authentication that you'll want to use from the Firebase Auth section in your Firebase console. After project setup and enabling Auth, you can get back to your code in your app. Using email and password sign-in is super easy. The first thing you do is register your user's email and password, which you can do by calling the create user with email and password method on a Firebase Auth instance. This will also automatically log in your user. If you want to sign in a returning user, you can use the sign in with email and password method just as easily. Next is email link authentication. This authentication feature takes an email address from the user and then sends them a link that they can use to sign in, proving that they have access to that email address that they use to register. Just like the email and password method, you'll need to enable email link sign-in from the Firebase console. This is actually an additional option under the email and password method, so you just need to activate the appropriate slider and save. You'll also need to enable dynamic links in the Firebase console, as these are used for associating your app with the user's email via the sent link. You may remember there's a few slides ago that enabling dynamic links also means that you need to add the SHA-1 certificate to your Firebase console if you're using Android. So it's kind of something to be aware of. So if you do plan to use this feature, you will need to include that in there with that setup process, or you can go back and update the app in your console to include it again. So it's not something you have to decide immediately. When you're ready to sign your users in, you'll need to email them a link using the send sign in with email link method, which, yeah, their names are just kind of like very straightforward in what they do. With this, you'll need to include the information for iOS or Android app packages, as well as the dynamic link for your Firebase project. If everything goes as expected, they should receive an email with the like the one in this screenshot that contains a sign-in link for your project. Clicking on that link should open your app on the user's device. When they do that, your app will immediately call the did change app lifecycle state Flutter method when opening. You can check to see if the lifecycle state is resumed and see if there's a dynamic link associated with the opened app. If there is, then you can handle that use case. Generally, the way you'd want to do this is by calling Firebase Auth's sign in with email and link method to retrieve a Firebase user. And then finally, you can update the app state data. The final auth type that I'm going to go over is Google Sign-In. So from my own experience, this is actually one of the easier third-party authentication methods to use, but it kind of makes sense because we did put it together. So kind of had that working togetherness to kind of help that along. So first, you'll need to instantiate the Google Sign-In object, then call the sign-in method on it. If the user's device is able to use Google Sign-In, then they'll be prompted with a sign-in dialog similar to this. After the user has selected their account, you will receive a Google Sign-In account object. You can use this to call Authenticate against Google's identity provider service. Once the user is authenticated, you can retrieve their auth credentials from the Google Auth provider. And finally, you can retrieve the Firebase user using their Google authenticated credential. Additionally, if the user's been previously authenticated, you can retrieve their Firebase user using the current user method. So next I want to talk about the two database options available in Firebase. The first one, Realtime Database, uses a simple JSON tree structure to store and access data. This data is stored and synced between users and devices, and its main goal is to provide a backend data storage solution without having to go through the tedious process of setting up your own database server, authentication schema, REST endpoints, and everything else that goes along with building a typical database infrastructure. The first thing you will need to do to use the Firebase Realtime Database is create a Firebase database object in your app. You can then create a reference to a specific node in the JSON tree data structure. In this case, that node is called messages, and it's a child of the root node. You can create as many references as you like, such as this part of the code, which creates a reference to the counter node and then reads the value from it once before printing it. After you have your reference, you can associate with the listener in order to take action on any data changes as they actually happen. Finally, I want to introduce a new graphical widget from the Flutter library called Firebase Animated List. This works like a standard list, but it'll animate as items are added or removed from it. And it works specifically for Firebase references to listen for data changes without you having to tie everything together manually. If this widget doesn't work for your use case, then there's also the Firebase list and Firebase sorted list widgets as well. And for reference, this is the same screenshot from the first real-time database slide with that animation list, so you can see what it looks like with a little bit more context. The second option, Cloud Firestore, is a database tool that allows you to group data using a document collection structure for straightforward access. It offers many of the advantages of the real-time database, such as real-time syncing, offline support, and scalability, but also supports basic queries in addition to direct data access. One thing that's important to remember is that Cloud Firestore can be used in conjunction with real-time database, as each can serve its own unique purpose within your app. So like most things in Firebase, it only takes a few lines of code to do the most common actions, like reading and writing data. By first getting an instance of the Firestore object, you can retrieve a child collection from Firestore. Once you have that collection reference, you only need one call to add a new document item to it, or another call that will retrieve all of the documents from that collection just once. Despite those two operations being simple, let's also look at something a little more complicated, like listening for changes in your data. You can do this by creating a stream builder object that listens to a specific path in Firestore and updates whenever new data comes down. While we won't get too deep into what a stream builder is, you can kind of think of it in a similar way to features in Flutter, except they're activated anytime new data is sent to them. This object can then check to see if a data snapshot is available. If it isn't, it can return a default UI widget. Otherwise, you can retrieve the data from that snapshot. Using that data, you can update your app's state and UI. In this case, we're using the length of a data snapshot to define how large a list view should be, and then displaying list tiles in that list using the actual documents that have come down from Firebase. So this question always comes up after discussing real-time database and Firestore, so I figured I would just kind of add a slide in to help with it. So both of these tools use a different data structure. The real-time database uses a JSON tree to store everything, and Firestore uses documents and collections. The real-time database also supports a presence feature that so you can know when users are connected to specific nodes, whereas Firestore supports queries against its documents. Real-time database only supports the US Central region for now, but Firestore has a variety of regions that can be used to make data transfer a bit more efficient for your users depending on where they are. And finally, there's scaling and pricing to consider. Firestore automatically scales really easily and allows for 1 million concurrent connections at a time, whereas the real-time database requires sharding if you're going to have more than 200,000 concurrent users connected to the database. The real-time database also charges a little more on storage and bandwidth use, whereas Firestore charges for reads, writes, and data, and less for bandwidth and storage. So it just depends on how you're actually using everything as you go along. You can also see I have a link here at the bottom that will go into all the details on the differences and similarities between these two to help you decide which of the tools is going to be the most useful for you in your situation. So while we've talked about database options already, sometimes you need to store and serve user-generated content, such as images or audio files, directly in your mobile app. You can do this using cloud storage for Firebase. Uploads and downloads handled by the Cloud Storage SDK are resumable, making them more resilient to changes in network connectivity. When a user's connection is disrupted during an upload, the SDK will automatically handle retrying and resuming, which can be critical when you're dealing with the kind of network conditions often encountered on mobile devices. Downloading content uses a similarly robust system, allowing users to receive their data once a connection is successfully reestablished. Once the user's content is uploaded, it can be shared with other users of your app using the same SDK And since you'll most likely run into situations where only certain users should be able to see or upload specific content, you can use Firebase's security rules system, along with Firebase authentication, to restrict content according to your app's requirements. That way, one person can't just pull the files or data of somebody else if they're not supposed to. When you want to upload a data object to cloud storage, you can get a reference to the storage path, and then create a storage upload task by calling put file or put data on your storage reference with the item that you want to upload, as well as any other metadata that you want to associate with that item. You can also save a reference to that task in order to pause, resume, or cancel the action. Downloading a file is similarly easy. You can specify a storage reference for that file that you want and then get it through its downloaded URL. Once you have that, you can pull down that file using an HTTP request, like we discussed earlier when we were going over the Etsy list item app. Once a response is received, you can retrieve the information that about that file and then use it inside of your app. So Cloud Functions for Firebase are single-purpose functions that are executed in a secure, managed environment for your Firebase project. They are powerful tools that let you handle complex logical operations from within Firebase, such as performing operations on your Firebase database or interacting with various other Google or external services. These are great for handling backend logic for your app without setting up a complicated backend. To provide a quick example, I have this function written using Node that is hosted via Firebase Functions. When it receives an HTTPS request, it'll get the date and respond with a hello message, as well as a current timestamp. You can call that function directly using Flutterfire's HTTPS callable object with an optional data map. And then you can listen for the results asynchronously to update your app's UI. So at the last FireConf, we also released a new product called Extensions, which are pre-made functions that handle common tasks for developers without having to reinvent the wheel. You can find them in the console to see what can work in your app. And there's still more of them that are going to be released over time. So this is something that'll just kind of keep expanding as we have more use cases for developers that we want to just kind of have ready to go. So while it's the only product I'll talk about today that isn't in the Firebase build grouping, app distribution is great for rapid prototyping when you need to work with non-developers. You can upload your APK or IPA file and add either a single person or a group to the console so that users can receive an email and download your app without having to go through the Play or Apple stores. And then they can give you feedback or work with your app before, if it's officially released to the public. So the final thing that I want to talk about is Firebase ML, which allows mobile developers to enhance their app's user experience by applying machine learning. Firebase ML provides a variety of models that can run quickly from the cloud with a high level of accuracy and detail. The out-of-the-box models allow developers to recognize text, label objects, and identify landmarks. Developers can also take their custom TensorFlow models and run them through Firebase's easy-to-use APIs. So Firebase ML is a little bit more complex than the other Firebase products, but it's still not too bad. In this example, the image and image rotation parameters are found prior to running this method, and how you retrieve an image will vary depending on the needs of your app. You can find a great sample that retrieves an image using the scanner utils to get the camera stream in the Flutterfire GitHub repo. Once you have all the necessary data, you can call process image on your Firebase ML object to get everything started. The two methods here that aren't defined in this snippet are concatenate planes and rotation into image rotation. Both of these are helper methods that you can find in the GitHub repo, but in short, they simply manipulate the image data so that they can be analyzed properly by Firebase ML. So we've covered a lot today. If you want to learn more about Flutter or Firebase in depth, then the top few links will give you a lot of information and resources, like code labs and videos. For Flutter, I highly recommend checking out the Flutter cookbook that we talked about earlier, and you can find more information about all the features available in Flutterfire on GitHub. So again, my name is Paul Ruiz, and I will be posting the slides for this talk up on Twitter under my account, as you can find here on the slide, or you can reach out to me directly through my work email address at ptreis@google.com if you have any fairly in-depth questions that you'd want to go over. With that, that is all I've got. So I'll pass it back.
That's awesome, Paul. Thank you so much. I've learned a lot. We really thank you for coming in, joining us in Ghana virtually. I hope most of them too have learned a lot. We have some questions for you as well, which
Awesome.
I'll be reading them out. Yes, from Slido. Let me see if I can get access here. All right. So I have this question.
Okay.
Yeah, so let me get it on the screen for you as well.
Okay, so I think we will move you.
Let's see. Let me see if I can stop sharing. Maybe that'll help.
Okay, Paul. So this is the question. It said,
Okay.
what is the future for Android dev as Flutter can perform well like a native app as Android and iOS? So is it for a less complex business need us with WordPress?
So that's actually kind of debatable. I think you can do a lot of the stuff that you can do with native Android and iOS with Flutter, but again, there's going to be the different trade-offs. So like we talked about in one of the earlier slides, let me see if I can just find that here actually. Let's see. So games are going to be kind of one of the bigger ones. So if you have something like there's like the Corona SDK, I think it is, where they can do game development a little bit easier natively on Android. There's also Unity and some other stuff. Or if you need to get to some of the native APIs like the camera or Bluetooth, unless you are okay using third-party libraries, which some companies are not, just because of security or compliance or whatever reasons, then you're going to have a lot more of a hard time actually getting access to those and channeling them over to Flutter. Just because you don't have a lot of the resources that are also going to be available. So it really depends on the situation, or if you're developing things for like TV, cars, watches, and what have you as well.
Okay.
So again, it just depends. Flutter is going to be good for some situations, and then native Android or iOS development will be better for others.
Okay. I think that answers the question. So we'll also be giving out some codes, some 10 voucher codes to those who want to study Flutter on with that. So we will also be passing out the codes out. I don't know how we are going to do this. So I don't know, Paul, if maybe you have something to ask, or maybe after you've answered the question, you have something to ask. And let's see someone answer something, then we can give the person a code to a voucher code to study free online and gain a certificate as well. So let me give you the next question as well. So we will finish this up within the next 5 minutes. Then from there we can just give us maybe some 1 or 2 questions for someone to answer. Then we give the person a code. I think that's good, right?
Oh, okay. I have to think of some questions.
So I have this question as well from Slido. Okay, so he said, can you develop a Flutter app for iOS without having a Mac? If yes, is it possible to test the app on a real iPhone using a Windows PC?
I don't believe so. I think just because of the way Apple and iOS is set up, you do need to have a Mac for that aspect. So you could write the code for it, but you wouldn't be able to test it.
Awesome. Okay, then I have this as well. Let me put it here. Okay, so why does the build time for Flutter in Android Studio take so long? Is there a way?
I don't know if did you say waste of time? I wouldn't say it's a waste of time. Honestly, who knows? Android Studio, I feel like, is really slow for normal Android as well. So I'm not sure if it's really a Flutter thing or if it's just the Android Studio itself is really slow.
Awesome. Okay. So I hope that answers. Yeah.
Yeah.
We have this also. Is that what is the difference between cloud store and cloud storage?
So Cloud Store is going to, or Firestore, I guess. Is that what you mean? Yeah, Firestore. That's going to be where you actually save like text or other references that way. So it's going to be actually saving data. Whereas cloud storage is if you want to save like blob information. So images, audio files, videos, that kind of thing. It's not text.
Oh, okay. Oh, okay. Okay. That's awesome. Okay, so we have this. It said, as compared to a native app, Flutter apps are usually bigger. What is the best way to reduce the app size?
I don't know. I would have to look into that one, actually. I'm not 100% positive.
Okay. Okay. All right. So let's move on. All right. So let me get in this. It said, is Flutter the best option when you are building apps that communicate with IoT devices?
It depends on the situation. So I actually really like them for communicating with IoT devices, especially using that Flutter Blue library if I have to do Bluetooth. Just because I can then make an app that'll work on iOS and Android. It's because you do want to get more people that have those mobile apps supported. Really, though, it depends on the situation. If you're just making something for yourself at home, Android native would probably just be as fine.
Okay, and I think I have this drop on YouTube from Kelvin. He said, "What is the future of Flutter compared with PWA, that's Progressive Web Apps, and what is the trade-off?"
So I mean, the trade-off itself, Flutter is actually working natively, so it's written with C++ and it's running on the actual device, not using some word interpreter and whatnot. It's just drawing everything out by itself using the same stuff that Android and Chrome uses. So it has that efficiency that goes along with it. As for the future of it, I honestly don't know. I'm hoping it sticks around. They're pushing for it. But I don't work on that team, so I'm not 100% sure what is all going on with it.
Oh, okay. I think I have this also on YouTube. Said, can from Yeps Maths, he said, can you develop Flutter apps fully offline without any internet in a way that you can run it?
I have not tried. I would assume so, as long as you have your packages downloaded. So it'll be similar to Android. If you're using a third-party library, you need to make sure it's actually imported into your app first so that you can include that in with your project, and then you would install it.
Oh, okay. So we have this as well. I want to create an application that works offline. What tools should I use? This look like it's similar, right?
Yeah, I think that's pretty similar. I mean, the app itself, if you're not doing any kind of network request or anything that needs the internet, you should be fine just using it as is once it's installed on a device.
Oh, okay. So someone is asking that can we always rely on Firebase all the time?
I mean, mostly it's 99.99% up. Like any product, I mean, we're developers as well. Things go wrong, so sometimes things go down. But I mean, it's very few and far between when it does happen. So I would say yes, but with a star.
Okay. Okay, that's good. Let's get in this. All right. So this said, I want to use Firebase phone sign in. I have added the package and SHA1, that's SHA1 fingerprint in Firebase, but I still get an error. App is not authorized to use Auth.
Yeah, so for something like that, it's going to be a little bit more in-depth. Let's see. So we have a Firebase support category you can go to. So if you go to firebase.google.com/support, you can actually reach out to our support team that's available 24 hours, and they would be able to help you figure out what's going on with that.
Okay, that's good. All right. So, Hannah, can you get in this? Yep.
Okay, so someone says he had an issue with Flutter Firestore on iOS and it increased his build time up to 20 minutes. Is this issue fixed? I don't know what he
I haven't seen an issue like that, but if it does, like if you're still running into it, what you can do is you can go to the Flutterfire GitHub account and add a new issue, and someone would be able to look into that. So me and a few other people actually are the ones that look into those SDK issues when they come up.
Oh, okay. So we have this as well. Okay. So he said, guide for getting internship in Flutter. I think we are not talking about this now. Yes. So I think that's all for now.
Okay.
Do you have any at your end?
No
Yeah.
questions. No more questions.
All right. All right. So I think that's all for now, and we'll be giving out the codes to our best, or I mean those who have stayed with us till now. We'll be giving out the codes, and we have 13 people on now. So what I like to do is the 13 people here now should send me a message right away here through my email. That's dropping the email. Okay, so send me an email right away. Right away. Send me an email right away with your name, and I will give you a code to study Flutter free online. So send me an email right away. I have only 13 people here. I want you guys to send me an email right away to get the code. Yeah, so thank you very much, guys, for joining us. Thank you very much, Paul, for also joining us. So, Hannah, you take over.
All right. Thank you, everyone. Like Shajak said, thank you so much for joining, and I hope you learned so much about Flutter and prototyping with Flutter and Firebase. And hopefully, you can do more work with the Flutter cookbook, just as Paul suggested. Thank you so much, Paul, for sharing all this information with us, and we hope to do more of Flutter in the coming times.
Yeah, thank you all for having
Yeah.
me.
Thank you so much, everyone. Have a great day.
Before you go, Paul,
Bye.
before you go, Anna, wait, Paul, before you go, can you answer this question for D for me, Didan? He said, can I deploy Firebase app without a USB cable on an emulator or simulator?
So with Android, at least, I know once you have that APK that you built using Flutter or just even native Android, you can generally do that over Wi-Fi if you have that set up. There's some ADB commands that you'd have to find. I don't know the exact process offhand, but I know it is possible.
Oh, okay, awesome. Awesome. So I think Didan, your question is being answered. You have to send me an email right away for your code, for your free code to study Flutter online free. So Didan, you have to send me that email right away. So thank you very much, Paul, for joining us. We are so grateful. We would like to work with you in the future. As time goes on, we would like to invite you to Ghana one day.
Oh yeah, definitely. All right, you guys have a good one. All right, goodbye.
Thank you so much. Thank you so much. Thank you guys for joining us. All right. So Hannah. So sure.
Bye.
So yeah. So bye now. So thank you all for joining. Bye.